This is the P7 Block 1 webinar to support the implementation of the new Glasgow City Council Numeracy and Mathematics Progression Framework. If you haven't already done so, please join the Microsoft team where you will find all of the shared documents relevant to the implementation of these new progression planners. The code on the screen is what you will need to join the team, and you can find it by searching in the Teams page. As we move to using the new progression planners, there are some things that will be familiar and other things that are new. The content that's intended to be taught in each primary stage is displayed on an annual overview as we're used to. The research hasn't changed, best practice hasn't changed, so we would still expect CPA approaches, starting with concrete examples, concrete materials, moving on to pictorial examples before introducing very abstract processes. Would still be the approach to introducing new concepts. We're expecting problem solving to still be at the core of our teaching, with lots of real-life context provided and lots of purpose to our teaching. High expectations of fluency with mental strategies, still very much a priority. So all of those calculation strategies, those mental agility strategies are still very much wanted. And the curriculum at the moment hasn't yet changed, although it is in the process of an improvement cycle. So at the moment, these progression planners reflect curriculum for excellence, and therefore the resources you have in school will still be pertinent for the delivery of the teaching points. The departure is a new structure. We have 6 teaching blocks outlined in each annual overview. Each block lasts around 6 weeks, and core number concepts will be revisited each block with bite-sized steps rather than spending 2 or 3 weeks even on a particular area of math. At the end of each block, end-of-block assessments will be available. They're in development just now, and this will enable you to check in and see how the content of the previous block has been managed by your pupils and provide additional information for your professional judgments in terms of on track or off track. In addition to the annual overview, we have medium-term planners which have been populated with suggested learning intentions as well. You will also find that there's more specification, more direction in terms of which calculation strategies are age and stage appropriate, and you will find a more directed number fact knowledge progression through these planners in terms of times table, learning, and so on. So our annual overviews look something like this. You won't be able to read the detail there. As I said, they are intended to be printed A3, but just to help you with the navigation of them, title of the plan is up the top, indicating which primary stage it would be aligned to. Across the top, you've got the headers for each block of teaching, and these also have indicated months in the calendar where you should be trying to deliver that block. Down the left, in the same way as we're used to, there are the organisers, the areas of the maths curriculum from which the teaching points have come. And then each block is running vertically down the page. So the blue area there is block 2, for example. As I mentioned, in addition to that annual overview, you will find for each primary stage 6 sheets like this one, providing a medium-term block overview. In the central column there, you've got the teaching points for block 1 as they appear on the annual planner. To the left, there's a column titled Support, which gives you the teaching points that come before in the progression. And to the right, there's a column headed Challenge to give you an idea of the teaching points that will come next in the progression. It's worth saying at this point that these indicate the previous step. So if you have pupils in your class who are working much further back in the development of their mathematics, you may need to look at other overviews, other year groups to find suitable learning points for them. But all of the annual overviews mirror one another, so that's to say that the teaching points in block 1 for primary 7 align with the teaching points in block 1 for primary 6 and 5 and so on. This means that if you're working across planners, you should be able to find a mini progression across them. Also on the medium-term planners, you will find suggested learning intentions to show how we might cover the content of the block in a 6-week time frame. The way they've been written reflects current trends of planning by which we run core number topics and wider maths topics in parallel. And we know that many successful job share partnerships plan in this way. The other reason for offering suggested learning intentions is to show the suitable language for them in terms of keeping them child-friendly, in terms of keeping them open such that the specifics of the differentiation of the learning would appear in success criteria rather than ending up having to have different learning intentions for different groups. We're aiming for one learning intention for the whole class so that in an inclusive way everybody can be working on addition, for example, but they may be looking at quite different parts of the progression of addition. So for the remainder of this webinar, I'm going to talk through the different teaching points, organiser by organiser. This is simply to guide you through the content of the block. You will find in planning learning experiences in terms of your lessons that you may touch on more than one teaching point in a particular lesson. So for example, we couldn't be teaching about any of the calculations without talking about place value. So it will be slightly separated, I suppose, but hopefully it will make sense in terms of the pedagogy and the suitable models that you might wish to use for putting across these points. So our first organiser is number system and number fact recall. The teaching points here reflect the similar teaching points in block 1 of other primary stages, but we're extending those skills, moving them on to higher order numbers. Okay, so I'll move on because these points are going to appear on the slides that follow. So in terms of the number system itself, we're extending our confidence with whole numbers up to 1 million in this block. Later on in the blocks for P7, we'll come around to numbers with digits after the decimal point as well, so decimals as well. But in this block 1, we're just revising whole number, making sure that we're still fine with counting and ordering numbers up to that value, and practicing again our partitioning in different ways. Now, importantly, as we move up through the upper school, through second level, we have drawn attention in these webinars to how important it is for our pupils to have skills in partitioning in different ways. And that's because that agility with partitioning means that they can partition it to suit the problem that they're being presented with. So for example, that bottom right written example offers 2 ways of partitioning 817,573. The first one is very much partitioning by its place value, by the columns, but the second one might be a more useful way to partition the number if we, for example, wanted to divide by 4, because then we've got familiar multiples of 4 to work with. So that's just an example to say that we need to give them that facility of splitting up numbers in different ways, because that will support them with all of our calculation methods as they come. In terms of estimation, we've built these skills up through primary 4, 5 and 6. Ultimately, the same process is true as we extend numbers up to 1 million. If we are wanting to estimate where numbers lie on a number line and we have only some marked increments, we need to look at the range of the section of number line that we've been given. We need to maybe look at the increments that we've got marked and start finding midpoints to help us divide that section of number line up, and then make our estimate based on those subdivisions. So we need lots and lots of practice with this. If pupils are struggling with this order of numbers, it's maybe worth giving them more practice with number lines marked in hundreds and thousands to ensure they've got that familiarity with how to find midpoints and increments. The digital tool, game you mean, like with the screenshot at the bottom left, is quite useful one because it's very manipulative. You can decide what increments and decide how many increments to give on the number line before having them estimate where various numbers lie. And ultimately, we want to give them the confidence so that when they're presented with something completely open, like the cartoon character holding a section of number line that has no marked increments on it, so she's just got a section from 0 to 1,000 with a pointer marking a bit less than halfway along, we need our pupils to think, well, what do I know? Well, I could mark halfway and I know that's 500. And what else? But will I subdivide again and mark the 250 and 750? Having some strategies to be able to break that up, break that down, and make their estimates in a reliable way. Related to that then, we want to be able to estimate answers by the time we're in primary 7 by using rounding. Okay, so in terms of that rounding, we really need to have that mental number line available to us so that we can easily think what the nearest 1,000 or 10,000 is. And what it enables them to do is to know approximately what answer they're going to expect. So underneath that top left blue box, you can see 4 estimates of calculations, one for each of the operations. We need that confidence of taking something like the addition problem up the top, 3,543 plus 12,456, being able to quickly round that to the nearest thousands and know that they're going to expect an answer of about 16,000. Because if you look across to the right-hand side, where you've got that handwritten incorrect calculation, having actually tried to complete the calculation, they have misaligned their digits. They've left align their digits so that now the place value is incorrect. And so they've ended up with an answer of 47,886. Now, because they've done an estimate and knew that they were expecting 16,000, then we should have alarm bells ringing and actually this is not a reasonable answer. What have I done wrong? Hopefully they can revisit that. And that's the sort of awareness and facility we want them to have, because in their real lives, as they go on to manage their own money and so on, they will need to be rounding and estimating all the time. So there's opportunities within IDL if you're doing enterprise work or whatever. There's just one example at the bottom there, perhaps creating batches of brownies for a bake sale or whatever. They need to have a look at those issues, those problems, and be able to estimate and get themselves to a point where they know approximately what they need to get together in terms of ingredients and go out and buy. So last couple of points for this organizer. I mentioned that these progression planners give a more directed approach to recall of number system facts. So there's really 2 areas for that idea, the idea of number bonds, which we've built up from number bonds to 10 through applying that to finding friendly numbers, finding tens, finding the next increment of a 10 on an open number line. And then we want them to be really familiar with number bonds to 100 because that really helps them with things like making change. So we want to avoid that really common misconception of trying to make both digits of a double-digit number add up to 10 in order to make the 100. So if you look at that first open number line example, many pupils will tell you that 69 plus 41 makes 100 because they want the 4 and the 6 to make 10 and the 9 and the 1 to make 10. But if they've internalized an open number line visual of making things up to 100, jumping up to 100, that should be far less likely to happen, because what we want them to be saying mentally is, well, I'm at 69, 1 gets me to 70, and then I need 30 to get to 100. All right, so we need lots and lots of practice with that, with jottings if necessary, and then them internalizing that so that they have that mental agility. On the right-hand side of this slide, we're talking about times tables. By primary 7, we do want as many as possible of our pupils to have quick recall of times tables, multiplication and division facts to 10 times 10. This is because by the time they get up to S3 and they're having to do the Nat 5s, which are timed exams and with problems offering lots of steps, we want to free up that mental that mental load, free up the working memory for them so that the times tables part is automatic. And if they've got the times tables up to 10 times 10, then formal column methods for multiplication become much easier. We do want them to have the conceptual understanding that a times table is repeated addition. We're adding that multiple again and again to get the sequence of the times table. We want them to recognize patterns and know the relationship between the different stations of the times table. So things like 5 times a number is half of 10 times a number. We want them to know that 9 times a number is the multiple before 10 times, because if they then aren't quite at the stage where they can recall all of the multiplication and division facts, they can use that conceptual understanding to help them. So if I was to ask you as a grown-up, what's 10 times 600? Then you'd know that was 6,000. If I asked you what 9 times 600 is, then you might use the 10 times 600 to help you. You would say 10 times 600 is 6,000, and I need to take 600 off to find 9 times that number, so 5,400. So we do want the conceptual understanding, but if they can get some of it automatic, all the better. So all of the original tried and tested methods like chanting and songs and frequent recall practice, really good. We also live in a world now where we've got lots of digital opportunities to give children individualized practice so that they're practicing the times tables they need to practice rather than having to do it whole class, which is really helpful. And it also means if they're doing it in, via SumDog or Hit the Button or Magma Maths, then it's their personalized, individualized practice. We don't have the situation that we still want to avoid where it might be a very public pupil versus pupil speed contest. Okay, so it should be an individual pursuit and an individual aim for improvement. Okay, moving on to our next organizer, addition and subtraction. You'll see as we talk through these teaching points how relevant all of that number work in terms of number system is to these methods. So we're going to be adding and subtracting up to 6-digit whole numbers with bridging. The column formal algorithm through these progressions is introduced right back at primary 3 without bridging, and then through 4, 5 and 6 with increasing complexity in terms of bridging and number of digits and indeed decimals as well. So we're going to look at that. We're going to employ our rounding knowledge and use of the inverse to help us. And we've got a couple of other teaching points here as well to talk through. So first of all, our basic skills in terms of addition and subtraction. What we want to embed in our calculation teaching is some of these skills around estimation and rounding. So it's a great discipline to have our pupils round first. So if they're going to have a go at 56,521 plus 8,204, it would be great if they can round that first and know that they're expecting 65,000. Then they can go on to working out the exact answer. Now, we want as many as possible to be using a formal column algorithm because it's the most efficient. But if they want to or need to still use a partitioning strategy like the one on the left-hand side, that's fine too. Both of these result in an answer that looks okay, given that we've got an estimate of 65,000. So we want them to ask themselves, does my answer seem right? And if it does seem right, then they can also go on to use the inverse calculation to double check. Okay, so if we've done an addition calculation, they would then either be using an open number line to count backwards and do the subtraction that relates to it, or a formal algorithm subtraction method as well to check that they're confident about their answer. Alongside that formal method, we also want to practice the mental agility of adding and subtracting 10, 100 and 1,000 to and from whole numbers. Okay, this is related obviously to the place value skills that we've mentioned already. And we want them to have that ability to count on in those increments of 10, 100 and 1,000. Okay, now you might think, well, isn't it too easy to be adding tens at this stage? But because of the order of numbers that they're working with at primary 7, sometimes it does become quite tricky. So if you consider this example here, 465,992 plus 10, what happens when we add 10 here is that they end up mentally having to bridge 2 columns and understand that we're moving into 466,002. Okay, and that place value and those zeros holding the places of the tens and the hundreds trips up many pupils. So the more we can practice that, and actually it's back to those counting routines, actually counting from one of these big numbers, counting on in tens or hundreds, really helps them to solidify how that number system works at this level. And sometimes that's where they come unstuck, where they're not so sure of, first of all, the place value of the numbers, but also how to say those numbers and what the pattern is next of that number word sequence. And we do so much work on that down the school when we're introducing numbers up to 100. We don't necessarily invest the same time as we're working with much more difficult numbers up the school. And the last teaching point under addition and subtraction is a very small bite-sized introduction to algebra. So it's a very familiar concept. They've been seeing things like this for years. Something, add 5 is 10. Or it might have looked like this, but in both cases, something, add 5 equals 10. So what we're laying onto that is this new idea that as they move up into secondary school, they will encounter letters being used instead of the question mark or the empty box to tell them that there's an unknown quantity here. Okay, and we can dispel early on that misconception that B stands for biscuits or brownies or whatever. All right, so this is literally the only little step that we need to do in this block. If you look forward to P7 block 3, we're going to revisit the idea of algebra and introduce a coefficient for multiplication. So things like 4b equals 20, that comes later. So you don't even need to do that part of the double page spread from your textbook or whatever. Just this one idea of one missing number with addition and subtraction. That's why it's in this organizer. Okay, moving on to multiplication and division. We've spoken a little bit about recall of number facts, so we'll be practicing those regularly. In this block, we've got a few calculation skills to revisit. It's worth saying that the block 1 of each year group tends to revise the skills that have been introduced in the previous year. So these teaching points will have appeared later on in the primary 6 progression too. We're revisiting them and making sure they're consolidated before moving on. So first of all, making our connections between our known number facts and something bigger. So 5 times 300, when our pupils see something like that, we want them to relate that to 5 times 3. And they will be able to work out 5 times 3, or they might already recall 5 times 3, and we can model it through to them to explain that 5 times 3 means 5 groups of 3. So we've got a group of 3 here, 5 groups of 3 here, adding up to 15. And over on the right-hand side, in the same way, 5 times 300 means 5 groups of 300. Here's one group of 300, here's 5 groups of 300, and that's why it's 1500 or 1500. They will tell you that because there's 2 zeros in the multiple, then there'll be 2 zeros in the answer. That's true. They might want to tell you, I just need to add 2 zeros. That is the pattern. That's valid that they're seeing that pattern, but the conceptual understanding is because it's 5 groups of 300, and therefore it'll look like this. If you want to bridge that gap and show them 5 groups of 30 as well in the same way, then that might provide a really nice number string for them to understand. Okay, something like this skill would lend itself really well to a number talk or to your morning starters for practice. We want them to make sure that they're really confident with this skill. And it's important as they move on to decimals that they understand that it's place value that is causing these patterns, not just adding zeros, because as we get on to digits beyond the decimal point, we need to make sure that there's no adding of zeros in that way. So we're going to be moving on to long multiplication in primary 7 later on in the progression. In this block, we're going to make a start at that and remember how partitioning helps us to do more complicated multiplications. So here we are, 24 tennis balls in a box. How many balls are there in 45 boxes? So we want here to show them how the distributive law helps to simplify a problem of this type, so that if long multiplication is really too abstract at this point, then they've got a strategy. So an area model or grid method looks like this. We've got 24 tennis balls. We're going to split up that 24 across the top so that it's in easy multiples for us. And we're going to split up our 45 down the side. Now, this particular partitioning has taken it right down to the individual tens, which makes it very easy. 10 times 10s and 4 times 10, and we've got 5 times 10 down there. So very easy multiplications, but now an awful lot of adding to do. And the difficulty here is there's lots of places to go wrong. It would be easy to miss one of those as we're doing our addition. So we want to, in this block, try and move pupils on to doing not so many individual boxes in their grid. So something like this would reduce the number of additions needed at the end. So, okay, split up one of your 2-digit numbers into the tens, but keep the other one just in its tens and units, means that we're only doing 6 multiplications and only have 6 numbers to add together at the end. And ultimately, if it's possible, we could move them on to simply partitioning into tens and units for both of the numbers they're dealing with. It's a step on. It means they need a little bit more confidence in terms of multiplying those tens together. So 40 times 20 is a little bit abstract, but if they make themselves a little crib sheet of multiples of 40, that can really help. And ultimately, they'll come to the pattern of 20 times 40 being related to 2 times 4. So once they've built this up in that way, here we've only got 4 numbers to add together. And this version, where we're splitting by place value into our tens and units, is directly linked to the formal algorithm for long multiplication. These are the multiplications that we're doing when we do column method. So it's really important to get them to this stage if possible before we introduce that formal algorithm. As we get to block 4 of primary 7, we'll then introduce multiplying whole numbers by 2-digit numbers using the formal column method. Okay, in the same way, we're revisiting short division, making sure that we're confident with this because we're going to use it with numbers with digits beyond the decimal point later on. So many pupils will still find this particular algorithm tricky, and often, even if multiplication facts are becoming confident in recall, the division facts are less so. So we may need to model through with something familiar to remind them how the algorithm works. And it's a good idea to do this in parallel. So I've laid out 84 with my place value counters here. And we're reminding them that this algorithm is saying, I've got 84 sweets, or apples if you wish, strawberries, and I'm going to divide them into 5 equal groups. That's what that algorithm is asking us to do. So if they wish, they could model it through with something physical or using the MathSpot digital versions of these manipulatives. So we're going to share out the 10s as far as we can. They can each have 10 sweets or cherries. And in the formal algorithm, that's the equivalent step of us saying, well, how many 5s have we, how many of the 80, how many of those 8 10s can we have each? And it's 1, all right? So we've just put 1 10 into each box, so we have 1 10 each, but we've got 3 left here. And we can't deal with those at the moment because we want to share between 5 groups. We can't put 1 in each group. So we need to exchange these up, add them to our 1s. Okay, in our formal algorithm, we can see that the 3 remaining 10s have been moved across into the 1s column. So we should have 34 1s. And that's why when we exchange, it looks like this, 34 1s. Now we've got these as individual cherries or strawberries or sweeties. Now we can do our divvying up in that way that we've been used to since primary 2. We can manage to give 6 each. So we put a 6 in our answer in our formal algorithm, and we're left with 4. So we've got 4 remainder 4. And we'll revisit the idea of the remainder and how to deal with that in other blocks. But at the moment, we're just making sure that the division, the short form of division, is becoming really familiar to most of our pupils. It's the only algorithm where the process happens from left to right. We spend a lot of time teaching pupils to remember to start with the units, but actually division, our short division method doesn't do that. All right, so when they are dealing with a division in greater digits, so here we've got 5-digit number, they need to be starting at the left-hand side. How many 5s can I make in 4? Nothing. How many 5s in 48? There are 9 and I have 3 left over. So I'm exchanging, bringing it to the next column. How many 5s in 33? I've got 6 and 7 and so on. So we then end up with remainder 4 in the same way. All right, so they need to be used to that process so that they can be familiar and use it when we've got decimals as well. All right, and then the last teaching point for multiplication and division is to bring back this idea of these families of numbers, squares, cubes, and then we'll talk about primes in a minute. So there's a couple of points for squared and cube numbers. One is the notation, so having the little index number up at the top right of the main number, and understanding why that's a 2, because it's that same number multiplied together 2 times, and then for cubed 3 times, and they'll get that idea of the power that they'll use later in secondary. we need to explicitly teach that and have them familiar with the way that sequence works. And they want to be recognizing when something is a square, particularly. In terms of prime numbers, at second level, we just really need them to have an awareness of prime numbers as sort of a special group that only have two factors. All right, so a prime number is a whole number that only has two factors. There's only one pair that multiply together to make that product. And the factors are always the number itself and 1. All right, so in terms of multiplication, the only way to make 7 is 7 times 1, and there's no other version, no other pair of factors that will make that product. Okay, in terms of identifying primes, for example, identifying primes to 100, that's actually beyond primary levels in terms of benchmarks. That comes into third level, but we're just starting an awareness of it. Okay, our final organizer for core number is fractions, decimals, and percentages. As I said earlier, all of these core number organizers that we've mentioned so far appear in every block of teaching. You will visit and have teaching points in all of those areas every 6 weeks. And that's to avoid the situation where you might inherit a cohort of pupils and they haven't talked about fractions since term 2 last year. It means that all of these concepts remain fresh and familiar, and we can build on them bit by bit. So we've got a couple of teaching points here, and the third one really crosses over into our beyond number teaching. I'll show you that shortly. So first one, use multiplication and division strategies to find a fraction of quantity. The equivalent teaching point of this in primary 6 is to use sharing strategies. So here we're asking our primary 7s to move on to using their times tables knowledge to help them, but they may not be there yet. So I'm just going to talk through the primary 5 and 6 teaching as well. So we want to, anytime we're talking about fractions or reintroducing fractions, offer some visuals. Pizzas are always great, so we need to understand that that pizza there has been split into 3 pieces, and if I ask them to take 1/3 of that pizza, they'd be taking 1 of the pieces. So in terms of our fraction notation, they need to be really confident that the top number is telling us how many parts we're interested in. So I would like you to take 1/3 of the pizza. That means I need to take 1 piece. And the denominator is telling us how many pieces that whole has been split into. Okay, if I'm taking 1/3, it means that I need to take 1 out of 3 pieces. They need to be really secure with that concept before moving on. So when they are trying to calculate a fraction of a group then, so we were looking at a fraction of a shape or a fraction of an object there with the pizza, but we can use that to help us with a fraction of an amount, fraction of a quantity. So if we want to use a concrete example, and this is what we suggest through primary 5, a sharing circle that looks a bit like a pizza or a familiar layout of thirds would be helpful here. We get ourselves 21 counters to represent that quantity we're working with, and then we use our familiar sharing skills from division to divvy those up. And we find that when we split 21 into 3 equal groups, into thirds, then we have 7 in each group. So 1/3 of 21 is 7. That method is the age and stage appropriate work for primary 5. It's dealing with what we call unitary fractions, where the numerator is just 1. Okay. As they move into primary 6, we ask them to do a similar thing, but with fractions where the numerator might be greater than 1. All right. So in primary 6, they would perhaps do the same thing, but be asked to find 2/3 of the quantity. In which case, they've worked out 1/3 was 7, but if they took 2/3 of that group, it would be 2 lots of 7, so it would be 14. In the same way, they could model it through with place value counters. Here we've got 2/5 of 65. So we've laid out 65 with the place value counters. Fifths is telling us we need 5 groups, 5 parts. So we're going to create a sharing grid with 5 sections. We know we've got to make 5 equal groups. So now, very similar to what we talked about in division, they would be sharing up those 10s and then realizing they've got 1 10 remaining to exchange before they can share that out as well. Once they've done that sharing out, they can very easily see now that 1/5 of that 65 is 13, but they've been asked to find 2/5. So 1/5 is 13, 2/5 is 2 lots of 13, so it's 26. Okay, now with lots of practice and lots of examples in concrete and visuals like this, they will be able to start making those links to what we want them to move on to, which is this abstract understanding of process, whereby they know to find 2/3 of 21, they're finding thirds, that means they've got to divide by 3. Divide by the denominator, that's 21 divided by 3 equals 7. That's giving them 1/3, and then multiply by the numerator. So the numerator here is 2. That means 2 times 7, 7 times 2 is 14. Okay, and if they're struggling still with that and you don't want to be getting counters out, then sometimes bar model will do the trick. So 21 is the whole. I've got to divide it into 3 pieces for my thirds. So 3 times what makes 21? 3 times 7 makes 21. That's telling me that 1/3 is 7, 2/3 is 14. Okay, so lots of visuals, lots of practice, and then they will get to the point where the times tables knowledge will be able to take over. We're also in this block linking what we know about fractions to percentages. We have introduced very familiar percentages by now, so they are aware of a half being the same as 50%, quarters being 25%, and tenths being 10%. We've visited that before in primary 6. So using these then, we have a very simple process to follow. What is the percentage as a fraction? And then we're using the same process we've just talked about in fractions. Now that we know that 50% is the same as a half, we can use our denominator to divide, and then it's the same process we've just been using. All right. Bar models and fractions are really helpful to model this through. So there's an example on the next slide here. Here's our process. We've got to find 25% of 400 millilitres. So what is this percentage as a fraction? That's our first question. What is 25% as a fraction? How do we do a fraction with 25%? 25 out of 100 is the equivalent. 4 25s in 100, so it's a quarter. And they probably need to get to the point where they just know those equivalences, these common equivalences. So we've got to divide our 400 millilitres into 4 equal pieces. 400 divided by 4 has been jotted down at the bottom of that example. That's giving us 100. So each quarter is 100 millilitres. 25% of 400 millilitres is 100 millilitres. And now that they've built that model, they might also be able to tell us 75% of 400. As I know 75% is 3/4, so I can multiply my 100 millilitres by 3. Okay, moving on then, we have 2 beyond number topics in this block, and that's the same across each block of the progression. We revisit shape and space again when we get to block 4. We've also got data handling teaching points in this block, and that topic will come back 4 times across the year. So as I mentioned, the block ones of each year group mirror one another. So we've got shape and space teaching points in block 1 for primary 7, talking about 2D shapes, and those equivalent teaching points appear in block 1 in all year groups. So that if you look across all the block 1s, you'll get the progression of 2D shapes. Good, so we have a lovely introduction of use of a protractor here in primary 7. You may wish to model that on the smartboard. Visnos, the link there, has got some really good demo tools that are great for modeling. Otherwise, I certainly spent a long time with a visualizer, with my own hands and a real protractor, modeling what should be happening in terms of aligning the 0 to one side of my angle, being able to measure it. If you have a reflex angle as shown in that picture, you need to either model measuring the opposite angle and finding the difference, or you'll need bigger protractors, or you could draw a straight line and measure the two parts of the reflex angle. Okay, nice to talk through the possibilities with the pupils of how they might attempt to measure a reflex angle when they've only got a protractor that goes up to 180 degrees. We're also introducing in primary 7 2 new vocabulary items. There's lots of vocabulary associated with shape and space. Here we've got complementary and supplementary angles, and these two describe angles which total 90 degrees and 180 degrees respectively. Okay, and so the type of activity we usually see around those is missing angles, and of course in that case we are using our addition and subtraction knowledge as well. Good. So also in shape and space we have a teaching point around symmetry. The progression of symmetry through the stages has moved from using large concrete objects to create models that have symmetry, things like butterfly paintings and so on in primary 1, 2. We moved on to looking at 2D shapes and mirrors and so on in primary 3 and primary 4. And by this point in the progression, we are moving on to applying our knowledge and being able to see how digital technology can help us with design and symmetry. Lots of possibilities with IDL sequences around design and architecture and particular areas of art. We've got 2 really nice online tools showcased here. I had a nice time playing around with them. I would suggest if you decide to use either of these, that you give time for pupils to explore how the tools work before potentially giving them challenges with constraints like make me a design with 4 lines of symmetry, or have them recreate a design given. But lots of possibilities there, quite enjoyable, quick lesson to be done around applying symmetry to design. Okay, and then in terms of directional language, by primary 7 we're using all 8 compass points. That's been introduced in previous year groups as well. We're using our knowledge of angles to describe turns and so on. And I would suggest, given it's primary 7 and you're likely going on a residential, that if you engage with the organisers of your residential trips, there may well be opportunities to cover off this learning whilst you're there. Certainly Blair Vaddock, our Glasgow Outdoor Learning Centre, has lots of resources online that you can either use if you're going there, but also at school. One of the things they've done is create orienteering maps for almost all of the Glasgow primaries. You'll find them at that link there, and if your school hasn't been mapped, then there's a facility for you to request that it's done. You might or might not be aware as well that there's a Scottish Schools Orienteering Festival. If you're really into that and you want to get involved, that's worth having a look at as well. Okay, and our final organiser for primary 7, Information, data and uncertainty. In block 1 here, we're talking about interpreting bar charts, pictograms and line graphs with different scales and keys. And the new learning, really the step on for primary 7, is that the sources should be real life sources from websites, atlases, social science textbooks and so on. Okay, rather than fabricated data that we're creating from school life or whatever. We're looking at real life stuff here. So a couple of examples. Guinness Book of World Records, you'll know, is a favourite for lots of pupils. They have fantastic double-page spreads. I think that one's highest transfer fees of footballers and so on. But you could probably find a double-page spread to suit most interests in that book. Atlases are great because they've got all sorts of graphs for temperature and climate and so on. So really engaging with these sources and being able to tell the story of the data that's displayed to them is a really important skill. You want them, yes, to be able to read individual data points, but also by this time be comparing data points, suggesting any reasons for differences in the data. So why is that country so much hotter on average than another? Linking their understanding across other curricular areas there, and ultimately drawing some conclusions from the data. And this is a life skill that they will need in terms of engaging with news and information to do with finances and so on as well. On this screen, just to make you aware of a couple of publications. Your school may or may not have subscriptions to something like First News or National Geographic. These are also publications with lots of rich data sources. There's also a really good website called Our World in Data that gives all sorts of data displays on different topics. Those two happen to be kind of eco-related, so if you want to link this with your eco-flags work or with a topic around climate change, then there's plenty of fodder online there. Interesting for pupils to engage with non-standard looking bar charts and understand how the different infographics work. It's part of their literacy. We have a table of examples of text that has been in our Curriculum for Excellence literacy guidance since it was published. Charts, maps, graphs, and timetables, circled there with the red dotted line, they appear there because being able to interpret and read information displayed in different ways is as much a literacy skill as a numeracy skill. And that's why information, data and uncertainty features as a beyond number topic in 4 out of our 6 blocks, rather than just a couple of times, because there's so much to get familiar with and it's absolutely crucial to lots of other curricular areas too. Just a last point on this to promote something that's been talked about in math circles in recent years. Consider, it says at the bottom in that blue box, consider goal-free problems. Now, goal-free problems is not rocket science, it's what it says on the tin. Provide a source and then don't ask a particular question about it or a particular set of questions. Just ask pupils what they can tell you about that chart or graph. And I would liken this to the skill of reading a whole text before trying out comprehension questions. We always say to children, read the whole text first. Don't just read the questions and then go back searching for the answers. So in the same way, for a data display to actually engage with the whole chart and understand what all of the pieces are telling you means that they have a greater understanding of what's going on and then are more likely to be able to answer your questions or indeed ask questions about it. So have a look at goal-free problems. There's quite a few blogs and things around. Education Scotland did some presentations on this style of task. in recent conferences. It's a very inclusive way of delving into data handling as well, because pupils can engage with the information on lots of different levels. So that's us got to the end of walking through the content of Block 1 for Primary 7. Please log any feedback you have using the QR code here. We are very much looking for feedback from practitioners as these progression planners are piloted for the first time next session. It's intended to be a 2-year implementation, and we will need to make updates as new curricular guidance comes out from Education Scotland. So please be encouraged to leave your feedback so that we can improve and make these as good as they can be for our teachers. I mentioned centralised assessments are going to be created for each block of learning, and information about those will be communicated early next session. Webinars like this will be taking place for each block of learning, so look out for dates around early September for the Block 2 webinars. They're all being recorded as this one is, so if you can't make the date that it's happening live, by all means watch the recording, and then if you have questions that you haven't been able to ask on the live webinar, you can email me or contact through the team as I mentioned. Many thanks for your engagement with this new framework. We hope that it's going to be useful. Just at the end of this presentation, there's a couple of slides with useful links that I've mentioned during the presentation, and a printable QR code placemat, which helps pupils navigate directly to MathSpot digital manipulatives. That's available to print as a PDF from the Microsoft team also.